Hello students, welcome back tutorial from the CAD NX. Okay, today we will talk about let's open the new file. Okay, today we will talk the is several functions like for example the rip function and the draft body. Also we will talk today about if you open the menu, the insert design feature, there is exist a groove, and we will see the three types of the rectangular, U-shaped, and the cylindrical groove. We will see the three types of the groove. Let's start with the rip. So let's draw the one sketch in order to understand the rip. So select the plane, okay, and draw the, for example, the rectangle, the any dimension, extrude it. Press OK, and for example select the sketch, this face, OK, and for example also again draw the one rectangle, for example in this position, and extrude it. The mostly the groove is not the groove, the rib is needed in order to strengthen the structure, strengthen the structure and making the supporting system that uses the rib functions and the rib sketch. So for example I would like to make here the rectangle, not the rectangle, the triangle rib, and in order to do this, for the select the sketch and select the plane where you want to make the rib, this plane, and okay, and from here and select the intersection curve and select this rectangle. So okay, and this center line will be the appear. This is required in order to create the rib. This is how there will be additional line. Press OK. So and open the more. Let's finish the sketch. Open the more. Open the rib. In the select the body, you have to select the whole featured body and select the curve. You have to select you see here the two types of the firstly the two types of the you have to create, you can create the walls, so perpendicular to the section plane and the parallel to the section plane. We will see the step by step to all this kind of all this kind of the rib. So in the select the curve, just select this curve, and in this case you have to select the perpendicular to the section plane and select here just and select the plane. Just in this case you have to select the plane where you want to make the groove, this plane, and draw the line here, rectangle line, and you can define the extreme values of your groove rib. For example, let's make it 10 and 10 and finish, and change the walls type the parallel to the section plane. So you will create the rib like this. You see, you can drag and drop to increase the wall. So also you can write here the symmetric value, for example 20. So you will obtain the such kind of rib in order to support this wall. So it is the one method of to create the rib for the rectangle features. For example, if you would like to make the rip in this kind of sketches from the edge to edge, it is the same, that it will be not the problem. For example, let's see this example. Let's delete this one and open the rip again, and select the plane here where you want to make the rip, that this plane for example, and press and sketch the line from the edge to edge, from this edge to this edge. So, and press the finish. So parallel to the section plane is activated, and you see here the rib is created from the edge to edge. There is no any difference between the previous example. So press OK. This is the how to create the rib on the surface and in the rectangle feature. So let's see the different type of the ribs for example in the circular cylinders. So let's delete this one and this also, and this sketch also. Let's select the sketch and select this face, press OK. Rectangle, not rectangle, the circle, draw the whole circle, extrude it, and press OK. In this case, to draw the rib, also the same, we have to first sketch, obtain the intersection curve. So this plane, and make firstly intersection curve on the cylinder. On this side, for example, if you would like to make the rib, so intersection curve is created. Now let's open the rib again from the let's finish this sketch and more, open the rib and select the body. The whole body is selected, and select the curve. Firstly you have to select the plane, that the middle plane where you want to make the rib, this plane, and press OK. And the same as draw, for example, the line in this case, in the first case, that line with the from the knot to edge, like this. And the same as the previous, you can define the distance from the here to here, for example the 10, and the same as 10 here. For example, it's just example, the numbers. So, and finish the sketch. The rib is created as parallel to the section plane, the method, and it's estimated to 20 millimeters. So you see here the obviously it takes the shape of the cylinder here, and it takes the shape of the rectangle straight line from here. So it is the how to obtain the rib, but how to obtain the rib with the cylinder shape. It is the same as the rectangle one, almost the same. Almost the same. In the case of the cylinder, if you would like to have the rib, rectangle, the triangle rib from the edge to edge, it will be a little bit different, and I will show now how to obtain the rib in this kind of rectangle, in this kind of cylinder from the edge to edge. In this case we have to use the swap function. We will not learn the swap function so far, but in the upcoming lessons we will learn the swap function. Now just I will show you how to obtain the rib with swap function. So delete firstly this and this one. In order to do the, let's draw the reference sketch. So press this face, OK, Firstly, make the project curve using the edge of the top edge of the cylinder, this edge. Press OK. Then draw the line here. Also additional line here with equal lengths. Then make them symmetric on the x-axis, and let define the distance between them. The distance between these two lines that refers for the width of the rib. Okay, if I will make it 10, so width of the rib will be 10 millimeter. Then using the quick trim function, just delete this part of the circle and convert that to the reference, into the reference, and press the finish. The same thing, let's do the same thing that on the bottom part of the cylinder also. Press this sketch and OK. Okay. Make the project curve, this part. Press OK, and draw the two lines, the same line as previous one, and make them symmetric. Let's define the distance firstly. And make them symmetric. I hope it works. And convert them to the reference line, and a quick trim of that part of the circle, and finish sketch. Okay, one more thing, the sketch this face. Press OK. The same thing, the draw on the rectangle face. Project curve this edge. Draw the line here. Make symmetric them, and define the distance between the two lines, 10. Then convert them to the reference line, two lines, and quick trim of the edge, this two sides. That's all. Reference the lines is created in order to obtain the rib from the edge to edge. Again, one sketch. Select the middle plane where you want to draw the rib. Okay. Now be careful to draw this rectangle. You have to select the exact points, the intersection points of the lines. Then connect this with this point and finish. So it is created. Open the surface, then swept on the select the curve. You have to select this rectangle and select the curve. Let's do again more again once again more. Firstly, that you have to select the guides. So let's select the guides. So we select these three guides that we draw as a reference line. So select this one, add new set. Select this one, add new set. And select this one, add new set. And sorry, let's select the curve, select this, add new set, and select this. For the select the curve, you have to select this rectangle and this one and this one. So you see, rib is created in the case of the cylinder from the edge to edge. So with the traditional way as previous as a rectangle, it's not possible to obtain the rib from the edge to edge. So it is the way of obtaining the rib in the cylinder case with the command of the swept. And upcoming lessons we will learn deeply about the swept function to obtain some complex surface elements. So okay students, let's see as a kind of obtain the ribs, not the rectangular ribs but with a little bit the complex ribs. Also we will see now the how to obtain the parallel to section plane ribs. So let's firstly delete this all the projects with all the sketches. Also this one also, no, we can continue with this. So let's first extrude it the higher height, and let's make it shell upper. Let's make the upper part shell and press OK. So we will make the shell. We already know how to make the shell that we already learned. For example, let's datum plane. Select the datum plane at the distance. For example, from let's make the datum plane from this distance, and distance let's make it like this. Press OK. And let's draw one sketch on this datum plane. Now sketch this datum plane and press OK. So let's sketch the such kind of arc and make geometric constraints of firstly make it a horizontal and make the tangent this line with this line. So finish the sketch. So I think it's not on the, let's just see the it is not on the plane. Let's delete this one. I selected different plane, so sketch this datum plane, this the created. Okay, so the arc here, and let's the line, and let's make it okay. Let's make it tangent and finish the sketch. So you see the line is created on the datum plane, created datum plane. So open the rip function, the selectable, the body is selected, and select the curve, this curve. You see the such kind of rib is created. You can change the direction like this, and you can decrease the value. You see the rib is created using the parallel to the section plane, so it is the parallel to the section plane. Also you can create the perpendicular to the section plane, so it will be the section plane is the perpendicular to the section plane. Also you can change the direction. No, so it is the two way of the obtaining the rib in the such kind of method. You see, you can make the perpendicular to the section plane, so direction of the rib is perpendicular, and this is the parallel to the section plane. And you can here the make the symmetric value and asymmetric value, so the thickness, and if you open here there is the cap, that's the offset. You can the make the from the section, that's the you can make the offset. For example, this offset, the 0, you can increase the offset value by hand or just by the writing. For example, the 15. This is the from the section plane, it means that this datum plane, so from the datum planes it increases also the 15 millimeters above. Also you can add the draft angle. You see the draft angle, for example, let it bigger 5, and let's preview from the top side. You see the draft angle is added 5 degrees. This is the one method of the obtaining the complex ribs. So let's delete this rib, and I think the datum plane, yes, let's remain the datum plane, and let's draw one let's hide first this datum plane, and sketch this bottom face. Okay, let's draw one cylinder here, for example, and extrude it. And let's again show the datum plane here, and sketch this datum plane. Okay, let's sketch one spline line, You can little bit play with the values of the spline line like this. Press OK. Let's convert this spline line into rip. Finish. Rip. Select the curve. This curve, you see the rip is created along the spline line. You can increase, decrease the value, or just write the exact value here. Also, we can make the different rip like this on that side or on this side, using the rip of the parallel to the section plane, or rip perpendicular to the section plane like this. So also one more thing, here in the geometry, in the cap, you see there is the from the section. At the section, it means that from the datum plane, and from the from the selected, also you can select. That's the from the selected. It means that the selected existing face. For example, this face of the cylinder, you can select the face, and you see it goes like this. If you, for example, did like this and increase, for example, the value here, you see it will go up from the surface. Or if you make like this, only just goes. Let's do this one, cap from the selected. So can select as a limit value of the surface of the surface, any surface, in this case the surface of the cylinder. You can that's the same as to put the offset from the surface, for example the 6, so it goes up from the surface of the 6 millimeter from the surface of the cylinder. Okay, that's all about options, possibilities, and techniques of the rip, and let's go on with the others today's features. Okay, next is the I mentioned is the groove. Okay, let's firstly delete all the projects related to the rip. So sketch, let's draw the cylinder before the study the groove. So okay, and finish sketch, and let's extrude it. Let's make it higher. Press OK. Open the menu, insert, design features, and here you see the groove. And there is the three types of you can obtain the groove: rectangle, ball end, and U groove. Let's see all of them step by step. Let's firstly from the rectangle, select the rectangle, and select the face where you want to obtain the groove, the face of this cylinder. So there will be you will obtain the dimensions of the groove. This is the groove diameter, is the inner diameter, so this is the width of the groove. Let's change this, for example, as you want, so 37, and let's main this n. If you would like to define the correct position, press OK, so the groove is initiating. So if you would like to put the correct position for a groove, you have to select this edge and this edge. You will see that the distance between this edge, and you can exactly write any number, for example 35, and press OK. You see the groove is created. It's a rectangle groove. You see the part is rectangle here, therefore it's called rectangle groove. Back it, and let's see the ball end groove. Also you have to select the face where you want to make the groove. So let's this face, and the groove diameter is 37. 37 represents this diameter, smaller diameter. So let's make it more bigger. Let's make it 50. It works. Press OK. So the same. This define that you can define distance by the clicking this edge and this edge. So let's make it 90. Okay, you see the ball and groove. So it's a ball and groove is created with the diameter of the 50. It was before the rectangle groove was 37, I think, the diameter. So back it. Last tab is a U groove. The same, you have to select the face selected. So in this case you will select the groove diameter. The elsewhere width is this width, the same, and the groove radius. Let's remain all of them the same. Okay, the same as previous two. So let's select this one and this one to select the distance, correct position 150. Let's press OK. You see the U-shaped groove is created with the diameter is 50 and the width of 13, and here the radius is 2.5. So this is the what about the grooves. So it is the three types of the grooves, and it is the outer groove. You can also make the inner groove. So in order to make the inner groove, let's select the sketch this face, press OK. Let's draw the hole here with the diameter of 50. Let's and extrude it on the other direction and subtract, press OK. So let's make its distance smaller. So let's draw the groove, inside groove for this hole. So again, menu, insert, design the features, and open the groove. So let's start with the rectangle groove. So select the face where you want to make the groove. In this case it's inner face, this face, and its groove diameter is 50. So it is the diameter of the hole, and its width is 13. So press OK. So it's create, and if you would like to define the position of the groove, you have to select the edge, and here you cannot find the edge of the groove. So in this case you can open here the static wireframe and select this dashed line in order to see the distance. So it's 30. So let's make it 30 exact number. So press OK. So the same, let's and okay, this one and the wireframe. Okay, this one, okay, you have to in this case increase the value, for example 55, and press OK. You will see the groove is created. Let's see the view section. You see, inner groove is created. So groove diameter should be the bigger the inner diameter. So in this case you will obtain the inner groove. This groove diameter should be, this was 50 and it should be bigger than inner diameter, groove diameter. So let's see one more again. Let it insert design feature groove, for example the U groove, the face, and it should be 55, correct. Press OK, and let's define the distance, for example from this edge, and like from the this distance is, let's make it 50. Press OK, let's it's shifted, and let's see this result. View, section, and section. So from this side you see the groove is created, inner groove is created. This is the method of obtaining 3 types of the groove. So I think there is no question about the groove. It's easy how to define the position and how to define the inner and outer grooves. Let's delete all of them, and the last of today's topic is the draft body. Let's draw the cylinder, smaller cylinder, for example like this. And about the draft, we have the learn, and we will today learn the draft body. It's almost the same, but there is also exist some differences. And let's make the sketch again, not the sketch but the datum plane of the method of the bisector. That's the middle of the two faces, so in the middle. Press OK. So in this case, open the draft. Here you see the draft from the edge and draft faces to the draft from the edge and from the faces. So let's from the edge, and from the here you will select the parting object. So in this case it is this section, and you will select here select the edge above the parting. So this edge, and select the edge above the parting, this edge. So and you will select the vector, this vector, and press OK. So you will make the draft, symmetric draft of this cylinder. Also you can make the draft, for example change the parting object on this side and press OK. It will be drafted along the length, height of the cylinder. This is the how to obtain the draft, and it is easy. That's all for the today. See you on the next lessons.